For today, we're going to be looking at combinations versus permutations. The first part of our work is going to be identify whether it's an area involves permutation or combination, and then find the number of possibilities. Now, yesterday I mentioned something about order. Like I came in, I said, if I have four letters, let's say I have the letters A, B, C, D, and I want to make groups of two letters. I could go A, B, I could go B, A, C8, and some more, right? I want to look at this too. In permutation, order does matter. So those two are considered two different groups. A, B, B, A are considered two different groups because order does matter. That's in permutation. In combination, that's considered the same group because I'm using the same two letters. So when order matters, we're using permutation. When order does not matter, we're using combination. Okay, so let's take a look. Sarah Wong and Joe are planning trips to 4 countries this year. There are 6 countries they would like to visit. They are deciding which countries to skip. So from 6 countries, they're going to go to 4. I don't see anything about any order. It doesn't matter which country they go to first. It doesn't matter about orders. So I'm just going to say, well, this one definitely has nation. Now find the number of possibilities. I have combination. From 6 countries, they're going to visit 4. So I'm just going to, the way we do this, I go 6 factorial over 4 factorial, or better yet, the way I explained yesterday was 6 factorial over 2 factorial and 4 factorial. Now my 6, you see where I got the 6 factorial from the top. My 2 at the bottom, I subtracted 6 minus 4. So this is 6 minus 4, and this is obviously the 4. So I have 6 factorial over 2 factorial, 4 factorial. Okay, what does 6 factorial mean? Is 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Now the 4 times 3 times 2 times 1 on the top, could I have just, each of them, could I have just called it 4 factorial? Because I know they're the same, so I know they're going to cancel out anyways. Instead of canceling the 4, then canceling the 3, then canceling the 2, I just cancel everything. So it seems like on the top, 6 times 5, I have 30. At the bottom, 2 times 1, I have 2. 30 divided by 2 is 15. So we use combination, and there's 15 possible solutions. Now looking at question number 6. A team of 17 softball players needs to choose 2 players to refill the water cooler. So there's 17 players, I need to choose 2. It doesn't matter which order I choose them. So I'm going to go with combination. Combination. Now I'm looking at, from 17 players, I'm choosing 2. So how do I work this? I have to go 17 factorial over 15 factorial, 2 factorial. Now 17 factorial, let me write that as 17 times 16 times 15 factorial. 15 factorial is 15 times 14 times 13 all the way to 1. And I stop at 15 factorial because I already have a 15 factorial at the bottom. I know those are going to cancel out. Now my 2 factorial is 2 times 1. All right, 17 times 16. Let me get a calculator to figure that out. 17 times 16, that is 272. 2 times 1 is 2. Now 272 divided by 2, that's 136. So it was a combination, and there's 136 possibilities that I can choose from. Now let's take a look at number 7. A team of 18 players need a team of 18 soccer players needs to choose a captain and a co-captain. Now there's an order, right? I need to choose for two different positions. It doesn't matter if I choose the captain first and then the co-captain or vice versa. The thing is, I'm choosing players for two different positions or two different orders. So this case, it has to be permutation. Now I'm doing permutation. I'm doing 18 permutation 2. Now, how do we do this? I'm just going to go 18 factorial over 16 factorial. At the bottom, I just did the 18 minus 2. I don't do 16 factorial and 2 factorial. It's only 16 factorial in permutation. Now, what's 18 factorial? That's 18 times 17 times 16 factorial. I already have a 16 factorial at the bottom. So those cancel out. Now, 18 times 17. Let me see. 18 times 17 is 306. Now, for number 8, there are 10 applicants for 4 jobs: computer programmer, software tester, manager, and systems engineer. Basically, there's 10 people, and there's 4 different positions I have to choose them for, 4 different jobs. So in this case, I'm doing permutation. If it said there's 10 applicants, and you're gonna get 4 jobs, but it didn't specify for 4 specific jobs, it just says from 10 people, you're gonna choose 4. It would have been combination. But in this case, because there's 4 different jobs, I have to do permutation. So I'm doing permutation from 10, I'm going to choose 4. So I'm looking at this as 10 factorial over 6 factorial. Now 10 factorial, I'm going to call this 10 times 9 times 8 times 7 times 6 factorial. I have a 6 factorial at the bottom, so they cancel out. Now 10 times 9 times 8 times 7. See, 10 times 9 times 8 times 7 is 5,040. I'm going to put a little comma to separate the thousands. Now, when you type this, make sure for the letter, the first letter, there's C for combination of P for permutation. Make sure you capitalize it and write the whole word combination or permutation. Notice that on each I did a column. It looked like a dot and a little comma. Now, there is a space. When you type it, make sure there is a space before the number. When you type this on my homework, make sure you type in that space in between them. And then on question number 8, see there was a comma because 5,040. I said I'm going to write the comma to separate the thousands. Now in your case, that little comma is optional. If you just type in the digits 5040, you're okay. If you type in the comma, you're okay. So when you have thousands, the little comma for the thousands is optional when it comes to typing. Now let's take a look. Find the probability of each event. Now here, take a look. I'm going to be looking at a 6 die is rolled 12 times. What is the probability that the die will show an even number exactly 9 times? Okay, so what I'm going to do is I'm going to be looking at what is the probability that the die will show an even number. So I'm looking at what's the probability that I roll a die, and it shows an even number, right? There's 6 probabilities. There's 3 of them that are even numbers. So 3 out of 6. Now 3 out of 6, can I just call it 1/2? So the probability of success, I'm going to look at success. I'm looking at what's the probability that I write an even number. And then I also have to look at a probability of failure. What's the probability I don't get an even number? Well, the probability is also 1/2. Now, I'm looking at 9 times. I want this to work 9 times. So I'm going to do in the success, my x is going to be 9. On failure, I want it to fail it 3 times. So look, I look at my probability of success is 1/2. I want it 9 times, so I do it to the 9th. On failure, I want it's 1/2. The probability of failure is 1/2, and I do it to the 3 times because I'm going to fail 3 times. Because it says it will show an even number exactly 9 times out of 12. So that means I'm going to fail 3 times. So far I have 1/2 to the 9th times 1/2 to the 3rd. And also, it doesn't tell me I have to fail the first time or the second time or the third time. So it just says I have to succeed 9 times. So I'm going to look at 12, choose 9. Now, what's 12 choose 9? Is 12 factorial over 3 factorial, 9 factorial. All right. I'm just going to call this 12 factorial over 3 factorial, 9 factorial. So that's what I have. My first half to the 9th is success. Failure and 12 choose 9. All right, I'm going to grab a calculator for this one. Now, can I just combine? Well, because it's the same fraction, can I just combine this as 1/2 to the 12? Because the same, we know from rules before that as long as they have the same base, we can just add the exponents. And then 12 factorial, 3 factorial, 9 factorial. Let me find out what that is. My 12 factorial, I'm going to do 12 factorial. In my case, I just did my factorial over, I'm going to use parentheses, 3 factorial times 9 factorial, close parentheses. So make sure I have 12 factorial over 3 factorial, 9 factorial. Okay, so I have that. And that doesn't look right. Let me see. What's 12 factorial is 12 times 11 times 10 times 9 factorial. What's 9 factorial? They cancel out. Here I have 3 times 2. All right, so let me grab my calculator. That didn't look right. So I have 12 times 11 times 10 divided by 6, 220. Okay. So I have 1/2 to the 12th powered times 220. What's 2 to the 12? 2 to the 12 is 4096. So I have this as 220 over 4096. Simplify as much as you can. I'm going to divide each by 4. Let me erase all this because of the space. erasing all my work just for the space. So I have that my answer will be 55 over 1024. Leave it as a fraction, simplify fraction. Now let's take a look at number 10. A test consists of 12 true or false questions. Student who forgot to study guesses randomly on every question. What is the probability that the student answer at least 11 questions correctly? Okay, so let's take a look. What's the probability of success? What's the probability of true? 1/2. And the probability of failure is 1/2 as well. I wanted to succeed 11 times and fail 1 time. But can I just call this 1/2 to the 12? Which is 1 over. I said 2 to the 12 was 4096. Okay, now what is the probability that the student answer at least 11 questions correctly? So let's say, I only failed question number 1. I get 11 right. Let's say I only failed question number 2, or I only failed question number 3, or I only failed question number 4. What's the probability that I fail 1 question? All right, 12, choose 1. So the probability I get 1 question wrong is 12 times. But keep in mind here it says at least 11 questions correctly. So that means I could also consider, what if I get them all right? How many probabilities I have that I get them all right? Well, there's only 1 chance, right? 12 plus 1 is 13. So I'm going to say have 13 possible out of 4,096. Simplify your fraction as much as you can. It is as simple as it can go. That's my probability. Now let's take a look at number 11. Basketball player has 50% chance of making each free throw. So what's the probability of success? 1/2. What's the probability of failure? 1/2. What is the probability that the player makes at most 13 out of 15 free throws? Okay, so can I just say, because failure plus success is going to equal to 15 times, so 1/2 to the 15th. Now I want to say, what is the probability that the player makes at most 13 out of 15? So I want to see 15 choose 14 and 15 choose 15. I want to see this. Now 15 choose 14, that's what? 15 factorial over 1 factorial, 14 factorial. That's 15 times. 15 choose 15 is 1 time. So there's 16. Okay. Now what's 2 to the 15th? Let me figure this out. 2 to the 15th is 32,768. Okay, so let me see. 32,768. Now, from those 2 possible cases, I wanted to miss 15th and I wanted to miss 1. Let me see, what is 32,768 minus 16. So 32, 752. I was looking at, it's better for me to find out the failure, because I only had to choose 15, choose 14, 15, choose 15. I didn't want to look at success because 15 choose 1, 15 choose 2, 15 choose 3, 15 choose 4, 15 choose 5. There were two more cases, so way too many more cases. Now simplify each as much as you can. Let's see, I can divide each by 16. And I get 2047 over 2048. Simplify my fraction as much as I can. Now let's take a look. You purchase a lottery ticket and your numbers are 531. Lottery official randomly selects 3 balls from a set of 7 balls that are numbered from 1 through 7. To win, your numbers must match the selected numbers in order. So the order does matter. What is the probability of winning the lottery? So from the 7 cases, I have 1 out of 7, right? What's the probability that I get a 5? My first number is a 5, 1 out of 7. Now I chose a 5, so there's only the numbers from 1 through 4, 6, 7. So how many 3s do I have in there? 1 out of 6 balls. How many 1s do I have? 1 out of 5 balls. Let me multiply all this. All right, order did matter, so I was looking at here. So I have a 1 on the top. 7 times 6 times 5 is 200. I remember permutation. My 7 times 6 times 5, that's the permutation. So my answer is 1 over 210. The way you type this is 1 over 210.